Hey guys, welcome back to the DAHKTUBE, and today we'll be doing functions. Now the aspects of function that we'll be doing is composition of a function and inverse of a function. So first we're going to start with composition of a function. Now function composition is applying one function to another. So for example, we have g composition of f of x. So this circle here represents the composition. So it says g composition f of x. So it's g applied to f of x. So the result of f of x is sent through g of x. Let's say we're given this example, f of x is equal to 4x plus 2 and g of x is equal to x cubed. Now because g comes first here, what we're going to do, we're going to use g of x as the basis. So that means x cubed is the basis. Now what you would do is anywhere you see x in the g of x, you're going to substitute f of x for it. So it's g of x is equal to x cubed. But because it says g composition f of x, so it's g f of x, right? So anywhere you see x, you're substituting what f of x is. Now we know that f of x is equal to 4x plus 2. So it's now 4x plus 2 cubed. Remember, whatever x is, we're interchanging it for f of x. Now let's say we want to find the opposite, f composition of g of x. Now, just like a while ago, because the f is first, that means we're using f of x as the basis. So we know that f of x is equal to 4x plus 2. So if we want f g of x, anywhere we see x, so anywhere we see x, we're replacing it with g of x. And we know that g of x is x cubed. So it's 4, we're changing the x to x cubed because we're substituting, plus 2. And that would be the answer. And if you realize that g composition of f and f composition of g are not the same, so they're not equal. So here we're given this example, f of x is equal to 3x plus 2 and g of x is equal to x plus 5. We're told to first find f composition g of x. So that's saying f g of x. So because f comes first, we know that f is our basis. So anywhere we see x, we're substituting what g of x is. So we have 3x, we're going to interchange it with x plus 5, so it's x plus 5, then we have the plus 2. What we'll do, to make this look neater, we'll expand the brackets. So it's 3x plus 15 plus 2, and that is equal to 3x plus 17. Now let's say we want to find g composition of f. Because g comes first, g is now the basis. So we realize that with g, x plus 5. So that means we're substituting the x for what f of x is, which is 3x plus 2. So it's 3x plus 2 plus the 5. So to make this look neater, it's 3x plus 7. And if you go back, you realize that f composition of g and g composition of f is again not the same thing. So let's try one more. So we have f of x is equal to x squared plus 6 and g of x is equal to 2x minus 1. So first we're going to find what f composition of g is. So again, because f is first, that means this is our basis. So we have x squared plus 6. And we're substituting anywhere we see x for 2x minus 1. So that would be 2x minus 1 all squared plus 6. And what we'll do is expand this bracket and group like terms. So if we expand this, it will be 2x minus 1 times 2x minus 1. So it's this times this times this times this, and this times this. So we'd have 4x squared minus 2x minus 2x plus 1. So that would give us 4x squared minus 4x plus 1. and then we'd have the plus 6 plus 6. So that would be 4x squared minus 4x plus 7. And that would be our answer for F composition G. Let's say now we want to find G composition X. Because G comes first, that means this is our basis. So anywhere we see X, we're substituting what f of X is, which is this here. So it's 2 times x squared plus 6 minus 1. And again, we want to make it look neat, so we expand the bracket. So it's 2 times x squared, which is 2x squared, plus 12 minus 1, which is equal to 2x squared plus 11. So now we're going to do inverse function. So the inverse function is otherwise called the anti-function, and it is a function that reverses another function. So we usually denote the inverse by this here. So if you were given f of x, the inverse of f of x will be represented by f inverse of x. Okay, so let's say we're given f of x is equal to 2x plus 3. Another way we could write f of x is by replacing it with y. So these are the same thing. Y and f of x are the same thing. So now we'll say y is equal to 2x plus 3. So now it is easier to represent and less confusing. So step 1, we change f of x and y. Step 2, we interchange x and y. So anywhere you see x, you're going to put y. Anywhere you see y, you're going to put x. So that means this is x is equal to 2y plus 3. The next step now is to make y the subject of the formula. So we have y here. First thing we need to do is get rid of this here. So because we're adding on this side, that means we're subtracting from both sides. So it's x minus 3 is equal to 2y. If you want y by itself, that means you have to divide both sides by 2. So now y is equal to x minus 3 over 2. And this implies f inverse of x is equal to x minus 3 over 2. So let's say we want to find f inverse of 7 using the same example. Remember, we just found that f inverse of x is equal to x minus 3 over 2. All we would do is anywhere you see x, you substitute 7. So this is saying f inverse of 7 is equal to 7 minus 3 over 2. 7 minus 3 is 4, so that's 4 over 2, which is equal to 2. So let's say we're given this example here. So again, first step, we change f of x to y. So y is equal to negative a third x plus 1. Now we interchange x and y. So x is now equal to negative a third y plus 1. Now we want to make y the subject of the formula, so we get rid of this first. So it's x minus 1 is equal to negative y over 3. We want to get rid of the 3 in the denominator. That means we're multiplying both sides by 3 times 3. So that's saying 3x minus 1 is equal to negative y. So now we're going to expand the bracket. So it's 3x minus 3 is equal to negative y. So now remember, anything that we're making the subject of the formula, we always want it to be positive. So that means we want a positive y. So that means we're dividing both sides by negative 1. So divide this by negative 1 as well. So remember, if you don't see a sign, that means there's a positive sign in front. So that means the signs are changing because we're dividing by a negative. So the positive 3x becomes negative 3x, and the negative 3 becomes a positive 3 equal to y. That means f inverse of x is equal to minus 3x plus 3. So now let's say we're given this question. F of x is equal to 2x plus 7 and g of x is equal to 3x plus 2, and you want to find f inverse composite g of x. I know this might look confusing, but the first thing you need to do is, because f inverse comes first and we're given f of x, that means we need to find f inverse first. So given that f of x is equal to 2x plus 7, first thing, y is equal to 2x plus 7. So we interchange x and y, so x is equal to 2y plus 7. We want to make y the subject, so it's x minus 7 over 2 is equal to y. So now we have what f inverse of x is. So now that we have what f inverse of x is, we need to substitute g of x anywhere we see x. So we have f inverse of x is equal to x minus 7 over 2. So now we want f inverse g of x. So because we have f inverse as a basis, anywhere we see x now, we're going to substitute what g of x is. So we have 3x plus 2. So all of this is g of x minus 7 over 2. So it's 3x minus 5 all over 2. And that's our answer there. So using the same question here, let's say we want to find f composite of g inverse of x and f composite g inverse of 2. Okay, so what you need to note is that this here is the same thing as saying g inverse f inverse x. So those are equal. Alright? So what we're going to do is first thing, we need to find what f composite of g is, then find the inverse. So f composite of g of x. So remember, f is first, and that means that's the basis. So anywhere we see x, we're going to substitute 3x plus 2. So because f of x is equal to 2x plus 7, g of x so it's 2 times 3x plus 2 plus 7. Expand the bracket, we get 6x plus 4 plus 7, and that is equal to 6x plus 11. Now, we have this here, so what we do, all of this, we're going to call it y. So y is equal to 6x plus 11. So to start doing the inverse aspect, we interchange x and y, so it's x is equal to 6y plus 11. We make y the subject of the formula. So it's x minus 11 divided by 6 is equal to y. That means f inverse is equal to x minus 11 over 6. So now we're going to try it this way just to test if it is actually the same thing. So we want to find g inverse first. So if g of x is equal to 3x plus 2, that means g inverse of x. So y is equal to 3x plus 2, interchange. Make y the subject, so it's x minus 2 over 3 is equal to y. So that's g inverse. Now we need to find f inverse. And f of x was equal to 2x plus 7. So that means y is equal to 2x plus 7. Interchange x and y, so x is equal to 2y plus 7. Make x the subject, so it's x minus 7 over 2 is equal to y. So now that we have the inverse of both, because g inverse is first, that means we're using this as our basis and we're substituting this anywhere we see x. So g inverse f inverse of x is equal to x minus 7 over 2 minus 2 all over 3. So we need to find the LCM here, which is 2. 2 into 2 was 1, so that's x minus 7. 1 into 2 was 2, 2 2 is 4, and all of this is being divided by 3. So x minus 7 minus 4, so that's x minus 11 over 2 times a third. That is equal to x minus 11 over 6, which is the same as before. So that's it, guys, and thank you guys for watching. See you guys next time.